In this lesson, we'll learn how to apply the constant multiple rule when taking derivatives. The constant multiple rule says that if you have a constant multiplied by a function, then you can take the derivative by keeping the constant and differentiating the function. In other words, constants can be factored out of the differentiation process. The derivative with respect to x of c times f of x equals c times the derivative of f of x. Let's go straight to examples and apply this rule. In each of these examples, identify the constant, apply the power rule to the variable part, and then multiply that by the constant. Find the derivative of y equals 2 over x. First, rewrite this into a format that matches our definition. The derivative dy dx. Now let's rewrite our function as 2 times x to the negative 1. That's following exponent rules. Now we have our function that matches the format in the definition. Let's pull the constant out and applying the power rule, that gives us 2, that's from our constant, times negative 1, that's bringing the exponent down, times x to the negative 2. And we can rewrite all that as negative 2 over x squared. Pause the video and try the next one. Find the derivative of f of t equals 4t squared divided by 5. This is a constant multiple of t squared. Let's factor out 4 over 5. F prime of t equals 4 over 5 times the derivative of t squared. Following the power rule, that gives us 4/5 times 2t. Or 8t over 5. Let's keep going. Pause the video and find the derivative of y equals 2 times the square root of x. Let's rewrite the square root of x as x to the 1/2. Now apply the constant multiple rule and the power rule, bringing down the 1/2 and subtracting 1 from the exponent. And we can rewrite that as 1 over square root of x. Try this one. Y equals 1 over 2 times the cube root of x squared. First, try to rewrite this in the form of a constant times x raised to some power. The 1/2 came from there, and I rewrote the cube root of x squared as x to the 2 over 3. The 2 came from there, and the 3 came from the index of the radical. And because we moved this to the other side of the fraction, we changed the sign. Let's factor the constant out and apply the power rule, and we get the derivative as 1/2 times negative 2/3 x to the negative 5/3, which simplifies to negative 1 over 3x to the 5/3. Find the derivative of y equals negative 3x over 2. Let's rewrite this as negative 3/2 times x. And recall the derivative of x is 1. So y prime is simply negative 3 over 2. So remember, the constant multiple rule lets us pull out constants and focus on the variable part with the power rule. Let's do some problems where we use parentheses to organize expressions before applying the power rule. Find the derivative of y equals 5 over 2x cubed. First, rewrite the expression with a constant times x to some power. Then differentiate it using the constant multiple rule and the power rule. And finally, simplify. Find the derivative of y equals 5 over the quantity 2x cubed. We can rewrite this as 5/8 times x to the negative 3. Taking the derivative, we get negative 15 over 8x to the 4. Let's try a few more. Find the derivative of y equals 7 over 3x to the negative 2. We can rewrite this as 7/3 times x squared. The derivative is 7/3 times 2x, or simplified, 14x over 3. Find the derivative of y equals 7 over the quantity 3x to the negative 2. Rewrite, differentiate, then simplify. I move this guy up here, so it becomes the quantity 3x squared. So you got to square the 3 and the x. Squaring 3 is 9. 9 times 7 is 63. Applying the power rule, we get 63 times 2x, which simplifies to 126x.